Set theory and the axioms of probability. For an experiment, A, B, and C are three events such that the probability of A is 2/3, the probability of B is 1/5, and the probability of C is 3/7. Part 1. If A and B are mutually exclusive, calculate the probability of A union B. As A and B are mutually exclusive, we can use axiom 3. Axiom 3 states that if A and B are mutually exclusive events, then the probability of A union B is equal to the probability of A plus the probability of B. So the probability of A union B is equal to the probability of A, which is 2/3, plus the probability of B, which is 1/5, and 2/3 plus 1/5 is 13/15. Part 2. By calculating the probability of A plus the probability of C, explain why A and C are not mutually exclusive. The following is a further example of what is known as proof by contradiction. Let's suppose A and C are mutually exclusive. Then we can use axiom 3 to calculate the probability of the event of A union C. So the probability of A union C is the probability of A plus the probability of C from axiom 3. So the probability of A is 2/3, the probability of C is 3/7, and 2/3 plus 3/7 is 23/21. But by axiom 1, the probability of any event cannot be greater than 1, and so this cannot be true because 23/21 is greater than 1. Hence, A and C are not mutually exclusive. A single card is drawn at random from a pack of cards. Part 1. Are the events of getting a 4 and getting a king mutually exclusive? Discuss. Getting a 4 and getting a king are mutually exclusive, as it is not possible for a single card drawn from a pack of cards to be simultaneously a 4 and a king. However, if the question had asked for the event of getting a red card and a king, they are not mutually exclusive because you can have a red king, and so on. Part 2. Calculate the probability of getting a 4 or a king. So let A be the event that we get a 4 and B be the event that we get a king. Then the probability of A is 4/52 because there are 4 4s in a pack of cards over a total of 52, which simplifies to 1/13. And the probability of B is also 4/52 because there are 4 kings in a pack of cards over a total of 52, which again simplifies to 1/13. Thus, the probability of 4 or a king, or means add, is actually the probability of A union B, and the probability of A union B is actually the probability of A plus the probability of B. The probability of A is 1/13, the probability of B is 1/13, and 1/13 plus 1/13 is 2/13.